Kelly, and today I'll be guiding you through teaching some principles of relative dating using this textured cross-section. There are multiple principles of relative dating. This image shows the principle of superposition, the principle of original horizontality, the principle of inclusions, and the principle of cross-cutting relations. We will be focusing on the principle of superposition and the principle of original horizontality today. The principle of superposition states that a sedimentary rock layer in a tectonically undisturbed sequence is younger than the one beneath it and older than the one above it. As we can see in these layers, the oldest rock is the teal rock, then the green rock, then the yellow rock, then the youngest layer of these four would be the orange rock. The principle of original horizontality states that the deposition of sediments occurs as horizontal beds under the action of gravity. As we can see in this image, the orange bed originally deposited horizontally. The irregularities seen in this bed now are due to weathering and erosion. Based on this principle, we know that this bed was not originally deposited this way. First, let's go over the legend. The oldest rock layer is the tinfoil. It is a shale rock deposited in the Triassic period. The next rock layer is the tarp. It is a mudstone deposited in the Jurassic period. The next rock layer is the bubble wrap. It is a conglomerate deposited in the Cretaceous period. The next rock layer is the plastic gridded material. It is a limestone deposited in the Paleogene period. The next rock layer is the felt. It is a siltstone deposited in the Miocene epoch. The next rock layer is the sponge. It is a breccia deposited in the Pliocene epoch. The youngest rock layer is the burlap. It is a sandstone deposited in the Quaternary period. Now, let's look at the cross-section. Direct the student to feel the cross-section and try to find the boundaries between each contact. Ask them where the rock layer starts and stops. The student will notice that the majority of these rock layers are tilted. Thinking back to the principle of original horizontality, we can deduce that the tectonic event causing these rock layers to tilt must have happened before the burlap sandstone was deposited. If the burlap sandstone was deposited before the tectonic event, then it would also be tilted like the other rock layers. We can use the principle of superposition to determine the lower rock layers are older and the upper rock layers are younger. The tilted layers makes it a bit more difficult to distinguish the top from the bottom. Have the student feel the tinfoil layer and the sponge layer. Which layer is touching the youngest burlap layer? The sponge layer is. With this information, we can hypothesize that the tinfoil layer must be the oldest layer on this map. Have the student feel the burlap layer. What is different about this layer? It is completely horizontal. Ask the student what they think must have happened in order for this layer to lay horizontally on these tilted layers. The answer is weathering and erosion. Finally, let's look at the map view. The only layer exposed on the map view is the burlap layer. This is another piece of evidence we can use to conclude this is the youngest layer.